Hi all, welcome to Tech Forum. In this video, let us talk about different types of browser storage. The web browsers enables a number of ways for websites to store data on the user's computer, obviously with the user's permission, then retrieve it when required. This allows the website owners to persist the data for long-term storage, save sites or documents for offline use, retain user-specific settings and more. Let us see some of the important use cases for browser storage. The first one is personalizing site preferences. You can change a site preferences based on the user data. Then persisting previous site activity. Also store the login state. Saving this data and assets locally so the site will be quicker to download. Also you can use the site offline without network connection. Also saving web application generated documents locally for use offline. Let us now see the different types of browser storage. The first one is cookies, then local storage, session storage. This both are part of web storage API. Then IndexDB, web SQL, then hash storage. The first one is cookies. This is the legacy approach for storing the data in client machine. Also, this was the only option pre-HTML5 web storage. The cookies helps to store client-side data to enable personalized experience to the website visitors. The cookies are created in server and sent to the client on response, and the data is exchanged to the server on every request. The servers can use the cookie data to send the personalized content to the users. Example, authenticated behavior. The cookies can be also created, updated or read through the JavaScript using document.cookie object. The reading of cookies through the JavaScript can be restricted with HTTP only cookie flag to avoid different security issues, example cross-site scripting. With this flag, the cookies are only available for servers to access. The setCookie HTTP header helps us to store the cookies in browser. So refer this for attributes, cookie attributes, expires, max age, domain, path, secure, HTTP only, same site. Also you should be able to define multiple cookies through the same header. There are two types of cookies. One is session cookies, then other one is persistent cookie. The session cookie don't specify the expires or any max age attributes, and this will be removed when the browser is closed. The second one is persistent cookie. The persistent cookie specify the expires or max age attribute. The cookie will not be expired on closing the browser, but expire at a specific date or length of time based on the configuration, either expires or max age. The cookies set on one domain is accessible to other subdomains based on the domain setting in the cookie header. These are some of the restrictions for the cookies. The first one is it can only store 4 KB of data, at least 4 KB of data, but this limit is based on the browser implementation. Number of cookies on domain is restricted based on the browser implementation, example 20 or 50, that is again based on the browser implementation. Total number of cookies across domains again restricted, example 300. The oldest cookie is removed once the limit has been reached in order to store the new cookie. This limit is again based on the browser implementation. The cookies lead to multiple security issues. It is now recommended to use modern storage APIs. We will be discussing further in the video some of the options. Still, the cookie can be used to store the essential application state. Let us now see the details on web storage APIs, session storage and local storage, part of HTML5. With web storage, web application can store data locally within the user's browser. Compared to cookies, the storage limit is larger, example at least 5 MB. The information is client side only and not shared to server. Server will not have any access to modify the data. The data cannot be shared between domains, including subdomains. Unique storage per origin, protocol and domain combination. The local storage object stores the data with no expiration date. The data will not be deleted when the browser is closed and will be available the next day, week or year until deleted. The session storage object is equal to the local storage object, except that it stores the data for only one session. Means the data is deleted when the user closes the specific browser tab. The data is stored as key value pairs in the storage, and all data is stored in the string form. When adding data to storage, it is implicitly converted to a string. However, when the string data is retrieved from storage, it needs to be explicitly converted to the appropriate data type using functions such as parsing. When dealing with objects, the JSON.parse and JSON.stringify methods should be used for serializing and deserializing the objects. The web storage API calls are synchronous, so it may impact the UI rendering. Refer local storage and session storage APIs. Yeah, this one like we can check for the browser support. The legacy browsers won't support web storage API. So better to check for the support and perform the operations. The local storage and session storage objects helps to set an item to the storage. Here you can see like local storage set item, then the key and value, and same way session storage set item, key and value. Even you can use this option also, local storage dot test. This is the key, then this is the value. Also retrieve when required. If you see here, local storage then dot get item, the key, then same way here session storage dot get item, the key. The individual items can be removed from the storage. If you see here local storage dot remove item, then the key, same way session storage dot remove item, the key. Also the entire storage can be cleared for the specific origin. So local storage dot clear, then session storage dot clear. As we discussed already, the local storage and session storage is not shared between domains. It is restricted to the specific origin, the protocol and the domain combination. Let us now see the details on IndexDB storage. IndexDB is a JavaScript based object oriented database. IndexDB lets you store and retrieve objects that are indexed with a key. Any objects supported by the structured clone algorithm, example videos, images, can be stored inside the IndexDB. IndexDB is much more complex to use than the web storage API, but it will help you to store much more data compared to session and local store. IndexDB is a way for you to persistently store data inside a user's browser, because it lets you create web application with rich query abilities regardless of network availability. This application can work both online and offline. IndexDB is useful for applications that store a large amount of data and applications that don't need persistent internet connectivity to work. The IndexDB API is asynchronous and it does not block the UI rendering. This API uses indexes to enable high performance searches for this data. You need to specify the database schema, open a connection to your database, and then retrieve and update data within a series of transactions. The IndexDB allows you to store significant amounts of structured data. This size is based on the browser implementation. The database is private to the origin, means again protocol and domain combination. So any other site cannot access another website IndexDB stores. Let us quickly see the details on IndexDB API. The first one is check for the browser support for IndexDB. Most of the modern browser supports IndexDB storage. Here window.indexdb, so means it's supported, else it's not supported. Then indexdb.open, so we are going to open the database. The database is created if not exist already. The first parameter is database name. Here we are saying DB name. Then next one is the versions. Versions can be an incremental number, anything. So whenever you want to change your database structure, you can increment the versions. Then you can have this error and success handler. You can perform any operations based on these handlers. Then another one is on upgrade needed handler. This is called after successfully opening the database. Here you can upgrade the existing database object if it is already exist, or even you can create a new object store. Here we are creating customers, then we are specifying the key path, SSN, the primary key. Then even you can create index if required. So we are defining two index, name and email. So the first one is unique false, means duplicate names can be there, but email is going to be unique. Then you can add the data into the object. So we are saying like customer data, we have some customer data defined, then we are storing that into the object store. Next one is adding data to the DB object. Get the transactions, here db.transaction, and specify the object name, our case customers, then the mode, read write, read only and version change. These are all the available modes. use read write for add. On complete and on error handlers. On complete handler is called after all the data is added into the object. Get the object store through the transaction object. So if you see here transaction.object store, then customers, then add the required data to the object store through object store.add object. So if you see here object store.add customer. Next one is delete. Again get the transaction for specific object store with the mode as read write. Then get the object store through the transaction object. Then again use the delete method by passing the object key. In our case is SSN is the object key, so we are passing that. So you can even handle the on success handler also if required. The next one is read data. Again get the transaction. Here no mode is specified, so the default one read only will be used. Then get the object store. Then use the object store.get method with this object key to get the specified object data. On error and on success handler can be used to process the error and success scenarios. So here you can get the data through this request.result.name. Name is one of the field on this object. So like this you can get all the required data from that object. Next one is update data. Get the transaction with rewrite mode. Then get the object with the object key. So if you see here we are getting this object store.get with this specific SSN. Then on success handler we are updating the required data.age equal to 42. We are making the age to 42. Then we are using this put method to persist the data back to the object store. Read all data. You can use this open cursor method to get the cursor. Then you can iterate the cursor through cursor.continue, so that you will be able to get all the object in a object store. Another one is open key cursor. This can be used to grab the customer's record object keys. Also you can use get all or get all keys is an alternative method, but this will impact the performance as the browser need to load all the object at once to the memory. But this open cursor methods use the lazy loading approach. The next one is fetch data based on index. Earlier we discussed on defining index for the object store. Here we can use the index to get the required data quickly. Again we can use this get method to get the object with the specified data. If the index is not unique, the get method returns object with lower key value if multiple records matched for the data. Let's say like this name index is not unique and this Donna, this is matching for multiple records. We always get one record with the lowest key value. But you can use open cursor or open key cursor to iterate and get all the records. If you would like to limit the range of values you see in a cursor, you can use an key range object. The browsers prompt the user the first time any given web application attempts to open an IndexDB for storage. Let us now see Web SQL database. Web SQL database is a web page API for storing data in databases that can be queried using SQL variant. The specification is based around SQLite. Web SQL database is not supported by all the browsers. The standard is now deprecated by W3C and IndexDB should be an alternative. Still this can be used in supported browsers, Safari, Chrome, Opera, Edge. Let us quickly see the details. Check for the browser support, window.open database. Then the next step is open database. Here we are specifying the database name, version, description, then the storage required. Then as a next step, create the required object. Here we are creating table, if not exist, customers, then with all the field names. So here we are using db.transaction. So even we can use read transaction for reading the data. Then once the objects are created, then you can execute all the required queries to insert, select, update, delete the data from the database objects. You can use all the kind of SQLite queries to manage the data within the database. Let us now see the details on cache storage. Cache storage is a storage mechanism in browsers for storing and retrieving the network request and response. It stores a pair of request and response objects, the request as the key and the response as the value. Any response objects can be cached, example HTML, JSON, images, etc. The cache storage API can be used with Windows context and also means the DOM context and also with the service worker API to enable offline access. Here we are going to talk more on the DOM context. Maybe I will be putting another video on service worker context. Though the cache storage was created to enable the websites to store network requests and responses, it can also be used as a storage utility. For example, we can store custom data like user preferences into the cache and can be retrieved when required. The cached data can be returned and used whenever required, whenever the user try to access those resources. Let us see the details on cache storage APIs. The first one is check for the browser support caches in window. The next one is caches.open with the cache name. So it will open the cache or create if the cache is not available. Then the next one is caches.hash. It will help you to check whether the hash store is available for the specific origin. Then delete cache. Then again caches.delete with the hash name. It will delete the specific hash store. So then list hash object. You can list out all the cached object from a specific cache store. So here all operations are specific to a origin cache store. We will not able to access the cross origin hash store. The next one is add object to the hash store. Hash.add method with request object or request URL. Browser fetches the data over a network and has the response to the hash store with the request URL or the request object as the key. So here if you see like data.json or even we can specify a new request data.json. Here the data.json file is hosted in the same origin, but if required, cross-origin data can be cached by specifying the complete request URL. If required, additional options also can be added to the request. Here we are adding some options, method, get, headers, what is the content type. Then we can add that options here on the new hash.add. So this is the hash name. The next one is add all, cache object dot add all. You can add multiple network responses to the hash storage. If you see here, we are having multiple URLs, today.json, then tomorrow.json. Then we are saying that this is the hash object dot add all URL. So browser will fetch all these responses through the network and add it into the hash. Next one is put method. Put method allows us to specify both request and the response objects. Request can be an URL. If the response is not specified, browser fetches the response through network and store into the cache. Even custom data, example JSON, can be added as a response to the hash store. Also allows to modify the response options, example content type. If you see here the cache.put, here no response. So browser will fetch from the network and add it into the cache. In this case, we are specifying both request and response. This is a custom JSON. So it will be added into the cache store. So this is the option. It can be used as a data store also. So whatever your preferences, your application state, you can store it through this option. Then even you can fetch it from the third-party websites. Also you can customize this JSON response object. So you can specify content type or any other headers required. The next one is delete from the cache. So you can use this hash.delete, then the request URL or the request object to remove the response object from the cache. The next one is get all keys, cache.keys. It will return all the cache keys available in the cache store. Then match, you can find an item in a cache by using the hash.match. Hash.match, here we are specifying the request URL, then it will return you the response. But here it will always return one response. But if you want all the responses, matching responses, you can use match all. Then you can response data, you can use some of this method to fetch the response data, like array buffer. It will returns the data as array buffer, then blob, then form data, JSON. So it will return the JSON data from the response object. Also you can use text to get the text data. Let us quickly see the demo now. Demo application is on Node.js with the Express.js. So we are having something cookies.html. Also here we are sending the response set header, set cookie, cookie.serialize, then session cookie is the one, then persistent cookie. So here we are specifying the max age for the persistent one. Then for this session one, we are not specifying any max age or expire. So here one different is HTTP only. So we are not specifying that here. So if we specify the HTTP only, the JavaScript will not be able to access the cookies. Now if I go to the cookies.html, I'm trying to display all the cookies. So document.cookie, it will give you all the list of cookies. Then next one is web storage API. So here again we are having some methods like add to storage. Same thing we already discussed. Local storage set item, local. Then again to test session storage. Here if you see, this is the way to add JSON into the store test object. Then you can use this JSON.stringify the object and set it into the store. Then another one is remove from storage. You can use this remove item, test local or test session. Even you can do a local storage.clear. It will completely clear the store for that particular RJ. Then another one is reading data from the storage. So here if you see, you can use this one, local storage.get item, the storage, the item ID. Then same thing with session storage. But to get the JSON data, you need to use local storage.get item, the object name. It will give you the object, but then you need to use JSON.stringify if you want to print it, or you want to use JSON.parse to parse the object. Then the next one is IndexDB. So here again we are having some customer data. I'm creating a test DB as we discussed, like IndexDB.open. Then if there is a error handler, then on success. On success, I'm just storing this DB object into this variable, so we can use this in the further methods. Then on upgrade needed handler. So we are going and creating this object store, customers, then key path equal to SSN. Then these are all the two indexes, name unique equal to false, then unique equal to true. Then we are adding this customer data into this store. Another one is add. We can add a new object. So here if you see again db.transaction customers, then we are using read write. So then on complete, it's all, once all objects are added, this will be invoked. But here if you see, like this is the new customer data with this SSN name and all those things. So we are using the transaction object store customer. Then like we can have multiple object here. That's what we are using for each. Otherwise, add that corresponding object into the store. Once it's success, it will call this on success handler. Then the next one is delete data. Same thing. Again, getting the transaction, getting the object store. Then through the SSN or the primary key, we are deleting a specific object. Then next one is read. Then again transaction. Here we are not specifying any mode. Then getting the object store. Then again getting the object through the object key. So on success handler, we can get the required data. Then again another one like read all. So same thing, only different is we are using open cursor, then cursor.continue and printing those values. Then update, then getting the transaction, read write, getting the object, changing the value, and storing that or putting back that object into the store. Yeah. Now let me quickly go to web SQL API. So here if you see again, first we are creating the DB and table, test DB, then with this memory, then we are dropping the table if it is already exist, the customer table, then creating a new table. It's the same SQL. SSN is the primary key, then what is the type and all those things we can do. There is a callback method. So it will on successful creation, it will call this method. Now again insert data. Again you can execute, you can get the transaction, then through that transaction you can execute the required SQL. Here we are inserting, we are 2 times inserting a different data, but same thing. Then read data, same SQL select star from customers through the transaction. Here we are using one difference is read transaction, not the actual transaction. Now we can like it will return you the rows object, then you can iterate through that. To update the data, I'm using this update customer query and updating based on a key. Then the delete data, again based on the key we are deleting it. Yeah, any SQL you can execute here. The last one is cache store API. So here again we are checking whether the browser supports it. Then add. During add we are doing caches.open. First time this will be get created. Otherwise it will return the same existing hash store. Now from there we are adding this new request data.json. I have this data.json into my origin server. Now the other option we already discussed. I am even adding some custom data here. So through this method data then put method custom .json, then I'm adding this response. Then add all we already discussed. I have data1.json, data2, data3 JSON in my origin server. So through add all method we are adding all these responses into the cache. Then if you want to check the hash status, you can use this hashes.hash, that hash store name. It will tell you, like it will return you the boolean with the status. Yeah, if I like a data hash it exists, it will say true. Test cache it is not exist, so it will say false. Then you can delete the complete cache store also through this method. Delete then the hash store name. Here like you can even delete the specific object from the hash store. So get that hash store, then delete the object, specify the hash key here. Then all keys you can get it and you can iterate through and print the data through this cache.keys. Yeah, then if you want to get a cache data, you can use this hash.match. I'm going to get the custom .json data. So this will give you the JSON data. I am using JSON.stringify for printing this. You can use JSON.parse to get the individual data. Let me clear the storage first. If you go into this application, then clear storage. So here you can select what storage need to be cleared, but I am going with all. Then clear site data. So the storage is cleared. Now I say first up, let me go and access this cookies.html. So if I go here and see, like right now there is no cookies. But I am going and accessing this. Yeah, now if you see that two cookies are created. One is session, another one is max age. It's a persistence cookie. Now if I click on this display all cookies, so it will display both of the cookies. The session cookie will not be available in a new browser session. Let me go into this web storage API.html. So right now there is no web storage. If I go to this, yeah, there is no data. Then if I go to local storage, there is no data. So what I'm going to do is, like, first I'm adding a data. So now if you see test local and test object, both are added into the local storage. If I go to the session storage, the test session is added now. But if I want to add now or read now, I can read it, test local data, then session data and JSON data. So if you want, you can delete it also. Then again, if you read it, so these are null, but I'm not deleting this data. Otherwise, I'm deleting both of this. So it's become null. Let me now access this IndexDB.html. Right now, there is no IndexDB created. So let me go and access this. Yeah, now testDB is created. Under that, if I go, there is a customers store with the name, email, and other detail. So what I am going to do is, maybe I can read all this data, or maybe reading one data. Then if you click on read all, it will display both the records. Then even I can add data. So again, if I go, yeah, if you see here, read all, now I have 3 objects. Now if I want to delete, I can delete one of the data. If I again go and read all, it only have 2 records. So right now I am going and updating a data. So click on update, again read all, now it became 42. So maybe I can refresh this DB. Then if I go to customers, I can see now 2 records. One is having the updated data. Let me now access this web storage API.html. So let me refresh. So right now there is no web SQL. Now I'm going and click on this create db/table. Now it's created. So test DB. Then if I go under, there is a table called customers. There is no data now. I'm clicking on insert data. So then if I read this, yeah, you can see 2 records are added. So even we can refresh this. Yeah. So if you see, there is a 2 records. Now again, if I want to update, I can update it, and if I again read the data, so it's updated to 45. So maybe if I go again, I can find it's 45. Now if I want to delete some data, I should be able to delete it. So if I read all again, yeah, I have only 1 record. So let me go here. Yeah, 1 record is deleted. Let me now go into this cache storage API. So let me quickly inspect it. Yeah, that's fine. Now if I go to this application, if you see this hash storage, there is no storage. So now let me maybe refresh this page. That's fine. Now first I'm going and adding something to the hash. So done. Now the storage is created. You see data hash for that origin. So it's having 2 objects, custom.json and then data.json. Now if I see the status of the hash, one is true as we discussed, this is the existing one, another one is non-existing. Now if I want to add additional add all, if you see three more objects added into that. So now then if I want to delete the cache, I can delete completely, but I want to delete 1 object from the cache. If I delete that, the custom object is deleted. I can even get all the existing keys here, data, data 1, data 2, data 3. Because all are on the same origin, because even you can use the cross origin request. Now if I want to get a cache data, so now right now there is no custom object. Maybe I need to add something to cache again. Yeah, it's a custom object came in. Now if I go and get the cache data, I'm retrieving only for the custom object. It displays the JSON data here. Now again we can go and delete this cache. If I delete this, the complete cache storage is deleted. There are multiple options to store the data at client side. Select the option based on your use case. For offline storage, use the cache API. The hash API is still not supported by all the browsers. For storing application state and user generated content, use IndexDB. The IndexDB require more effort to implement. IndexDB is supported by most of the browsers. Cookies still can be used to store the minimal data the server required to identify the state. The local storage and session storage can be used to store minimum data, easy to manage the data. Refer this specific URL to access the demo files. I will be updating the URL in the video description. Feel free to provide your comments. Thanks all for watching the video. See you all in the next video.